So this question is looking at ionisation energies. What we're doing is we're seeing if we can identify an element from these ionisation energies. So what we've been shown here, remember we need to know that ionisation energy is the amount of energy required to remove an electron, each electron in turn, starting from the one furthest from the nucleus and working our way back in. So we can see that we're moving 1, 2, 3, and then there's a quite substantial jump. This shows us that there were 3 electrons in the outer shell, and this 4th electron needed to be in a new shell closer to the nucleus, had a little bit less shielding, and so there was a stronger nuclear attraction holding it on. A lot more energy was required. So we've got 3 outer shell electrons, which equals, it's in group 3. Things with 3 outer shell electrons are in group 3 of the periodic table. So then you would need to look at your periodic table. And when you're looking at your periodic table, you can see that nitrogen's in group 5, phosphorus is in group 5, aluminium is in group 3, so it's kind of tempting to pick aluminium, but boron is also in group 3. So there's obviously a tiny bit more to this question. So then you've already eliminated A and B, so it's between C and D. Aluminium is element number 13 in the periodic table, and boron is element number 5. So now I can say immediately that it can't be boron, it has to be aluminium. And how do I know that? Well, if boron is element number 5, it only has 5 electrons in total. This element keeps going on past 5 electrons, 6, 7, 8. I know aluminium has 13, it doesn't say this is all the ionisation energies, it says it's the first few. It can't be boron because boron should only have 5 electrons, so it must be aluminium.